And hello friends, welcome back. So we're going to continue where we left off. We just want to do this integral here, and then we should be done. Okay, let's see this integral and check out what our thermal profile should be. Temperature profile, where are you? This thing is so long. Maybe I should break it up into sections, yeah? Yeah. There you are. Okay. Yeah, I should break it up into sections. It's not the Leibniz rule part. Okay, just for clarity and ease, I'm gonna add some headers here, so it's a lot easier. Okay, okay, let me put that in here. Okay, so now we'll need to integrate this term. Integration should be easy. Save it up. Integrate from 0 to x t minus t infinity equals to, okay, I'm going to bring ts minus t infinity out. Integral from 0 to x of and times dx of exponential whatever this is. Okay? I'm going to copy and paste. That's the good part about using LaTeX. Copy and paste. Okay. Now we have that. Let's just do some integration, and we will just see delta t pop out. That will pop out here. In fact, minus delta t will pop out. Then we are supposed to evaluate this exponential at x equals to 0 to x equals to x. Okay, so now very simple. We'll have x as the first one. Okay, then we'll have minus exponential of 0, which is just 1. Okay, never mind. I'm just going to put 1. Okay, and of course this term should be very much smaller than unity, so I'm just going to delete that. And the minus signs will cancel. Okay, the minus signs will cancel. And that's what we will have. Okay. Now we can substitute back. I've been using this word a lot. Substitute back, substitute back, substitute back. Okay, so wherever we have this integral, we will have to replace with this term. Okay, and then we are pretty much done. Anything after that will be tidying up for the momentum equation. Okay, and what do you notice? Most of the terms here are in terms of this momentum boundary layer thickness and Q. So we might want to just replace it by Q over delta. Okay. Okay, we'll do delta P over Q. Yeah. delta P over Q. That's what we will have. And basically that's our first equation. Sort of done. The momentum equation. Momentum equation transform. Okay. After substitution. Okay. And I'll do subsection. Now on to the energy equation. Yeah, boy, I'm using so many subsections now. Losing count. Okay. Let's see. Where should our substitution of yeah? Let's do this one. So there are only two terms to substitute, but don't be too deceived at whether it's so simple, because the moment we have v and t in the same term, then we kind of got to integrate. Okay, so I will need to do something very simple. Well, not simple, but simple enough. This thing here will need to take the minus sign out. Okay, I'm going to take the minus sign out. I'm going to swap this around so that it at least looks like the variable we're trying to substitute in. So I'm going to swap around the signs. I'll bring the minus sign out. Okay, next thing I'm going to do is I'm going to quickly do a product one here, and the v, x, and y. So that will just be all of this copy and pasted down. Alright, so now we kind of know the tricks. Okay, we know the tricks, so you just need to be very careful. Okay, again, Vy we can actually bring it to the front. Vy we can actually bring it to the front because that won't actually have anything to do with x. Okay, so yeah, we can pretty much start integrating. After we multiply in the exponentials. So let's multiply in the exponentials. 1 here, then we'll have 2 over here. Okay. And then we'll multiply in this delta p. Okay, the x over delta p part. Two x here. Okay. Now we got it. I don't want two pluses over here, but that's what they seem to be giving me. Then I can remove this first exponential. So basically we'll just have to do partial fractions twice, or rather just combine these two things twice. Yeah. It's not as tedious as the first one, but still pay some attention, you know. Okay, so delta p, delta t will be at the bottom, and then we'll just have to add them up on the numerator. Phew. Let's see if it looks right. I forgot the plus sign. Plus sign on top. Yeah, the number of brackets is right. In fact, I can just remove one set of brackets. Okay. Is that... Okay, the less brackets the better. So I'm just going to replace these two with the same things. Okay, and now we should be ready to integrate. Okay, so what are we going to do? We'll have this integral here. And then I will just substitute this integral in here. Okay. Now I'm going to bring out the two constants with respect to x. Okay. Next thing we're going to do is to start bringing those fractions out. And we're going to invert them. On the first exponential and of course on the second exponential. Remember, these are with minus signs. So I'm going to take out the plus here and put it at the bottom. And the other one we'll do the same, except it's with minus 2. Now I'll take out the integral, since we already started the process, and we'll just evaluate. We'll just evaluate this whole term at 2 points, yeah? X equals 0, and of course x equals to big X. And now we'll just get rid of some minus signs. And that's it. Okay, so one coefficient in front, the other coefficient over here. So let's evaluate that. Evaluate at x equals to x, which I think by now I don't want to evaluate anymore, because I will just say that at x equals to x, we find that it is negligible with respect to the first term. Okay, it's negligible with respect to the first term. So I'm only going to evaluate at x equals to 0, then I'm going to flip the signs. So yeah, I'm just going to evaluate this whole term at x equals to 0. Of course, it's a minus. Okay. Yeah, it's a minus, so let's just do that. I'm going to have a minus here. I'm going to have a plus in front. And I'm just going to evaluate only at x equals to 0. Okay, so that's what I'm going to do. I'm just going to evaluate this at x equals to 0 because the other term is just negligible. Okay, so now x equals to 0 will just reduce these two terms to 1. Okay. So now, again, yeah, we'll need to do, I mean, here the subtraction is pretty straightforward, right? I'm not too much of an issue, because the denominators are pretty much the same. Yeah, the denominators are pretty much the same. Okay. Anyway, did I mess something up? There should be a half at the bottom instead of on top. So, all right, let me correct that quickly. Oh, yeah, we're integrating, so yeah, this thing should be a half. We're not differentiating, so we have to flip everything on its head. Okay. So instead of 2 becomes half. So everywhere I see the 2, I should be putting a half there. Okay. So okay, this math is pretty straightforward. Subtract it from both sides, you will just get a half. Okay. I hope I'm not doing things wrong. Yeah. Okay, yes. I think bad news. I found that I'm doing things wrong. There was a careless mistake. At least good news to have found that careless mistake, but still, it's a careless mistake. Yeah. This part. Okay, again, if it doesn't interest you, can just go on, skip ahead. So this 2 should be not outside, should be inside. I'm really trying to skip the math a bit too quickly. There's a price to pay. Alright, so delta P will be 2 times. I'll take the 2 out. There'll be no half anymore. Okay. Again, delta P will be 2 times. Oh man, this burns. Okay. Yes, do feel free to just skip ahead if you don't want to watch this part. Oh, why not? I just fast forward it for you. Okay, should have corrected most if not all the careless mistakes. So anyway, I've come to this point. Now I've come to this point, and now we can just evaluate it at x equals to 0. Not x equals to x. And doing so, okay, doing so, excuse me. Yeah. Let me delete those exponentials, because they are just reduced to 1. It's a little bit hard to see all this code. Okay, this exponential and this exponential will be dropped off. And let me delete the brackets just to reduce the confusion. The last line I will also delete. Okay, there's almost like at the at the end of the tunnel pretty soon. Okay, so these two, okay, now we'll just combine the fractions, and even before that, before combining, we are going to convert it into a going to reintroduce q, where q is equals to the delta p over delta t. So divide top and bottom by delta t before we combine the fraction. So it should make life a lot easier for us. So of 1 plus q at the bottom, 1 plus 2q here, and both on top will be just reduced to delta p, and that makes the combining of fractions less tedious. Okay, so now we can just factorize this delta p out of here. And of course, let's just do some subtraction. Okay, simple subtraction. 1 plus 2q on top here. Okay, 1 plus 2q. 2q. So we will have a minus 1 plus 2q plus 1 plus q. Minus 1 plus 2q plus 1 plus q. And that will just give us a net negative of a minus q. Okay, I hope to have gotten this right. Okay, so this thing will just be the q will be on top. Okay, there will be a minus q on top. Yeah, and that will be our integral. Well, there are two minus signs here. Okay. Let me get rid of the extra minus sign. And we'll have a minus q on top, not minus 1. Okay. So we have this integral now in this form. Okay, then we substitute back. Okay, now onto the energy equation will be here. So this integral will be substituted out completely. We'll just get this. Alright. Okay, so good thing though, both of these minus signs will cancel out and it will make life easier. I won't say it's easy, easier. Okay, the ts minus t infinity can be put outside. And let's put the delta t back in here. Okay. Now I'm just going to divide both sides by ts minus t infinity, and this dt here will become d theta. all sides by. Okay, but anyway, that's for the next video. Yeah, it's already way too long. So yeah, I'll stop here. I'll see you next time.